Yes, so like I said in the previous video that we're going to be treating one exercise from our TD, which is going to be this one. And so now we're in TD. Un mobile M se déplace dans un plan et repère par ses coordonnées polaires R et θ telles que R de t est égal à 2 moins exponentielle moins t et θ t est égal à moins t plus pi sur 2. Now, U est en R et en mètre et en θ radian. Remember when I said in the previous that when we are treating coordonnées polaires, you'll be given R, you'll be given θ, and then you work with both. Now, what's it trying to say? The first part is that a mobile, we denote that mobile as M, is displaced, and then by the coordinate polaire R and θ, such that R in function of time is 2 minus exponential minus t, and θ t is equal to minus t plus pi over 2, where R is in meters and then θ in radians. So the first part of the question, we're asked to determine the composante radiale VR de t et transversale Vθ de t de la vitesse de m à tout instant t. So here we're asked to determine the composante radiale. Remember in our previous video, I'll bring it back so that we remember. We said VR is our composante radial and it's gotten by deriving R. Yes, so it shouldn't sound bizarre. And then Vθ composante transversal is gotten by deriving θ and multiplying it by your expression of R. So that's the composante transversal and the composante radial. So now that's exactly what we are being asked to do, to determine the composante radial VR de t and the transversal Vθ de t de la vitesse de m à tout instant t. Okay, for me, I like, first and foremost, I like bringing out the données. That's the giving details of that particular question. So solution, especially in physics, most especially in physics. So solution, we've been given RT to be 2 minus E 1t, and we've been given θ t to be equal to minus t plus pi over 2. And then they said R is in meter, and then θ is in radian. Another thing I do, this is like a secret to the Anglophone students, I translate it to English. Most times I translate my questions to English. Every single word I translate it to English. Then I think, like, this is the question. Okay, so what am I supposed to do? So you can also try that method as well if you think it will work for you. So R that is 2 minus exponential minus R is this. So we're asked to find what determine the composante radial a composante transversal. So we know that our composante radial is VR de t. So we're talking about what? Vector vitesse, composante de la vitesse. Yes. So VR de t, it's, like I said, it's tout simplement dr sur dt. So we're deriving 2 minus exponential minus t. So how do we derive this? It's 2 minus something, so we derive it one by one. The derivative of 2 is a constant, so out. We're left with minus exponential minus t. So when you're deriving let's look at exponential minus t alone first. When you're deriving something like exponential minus t, where am I going to put this? Okay, I'll put it here. Exponential minus t. This comes here, so it becomes minus exponential minus t. So you're having minus exponential minus t. So that's minus exponential minus t times this minus. So you're having what? Plus exponential minus t. Then for, yeah, that's all for composant radial. Yes, that's what you're thinking. Then composant transversal is v theta to t, and we say v theta to t is r d theta over dt. Another thing is formulas are very important. At least you get 0.5 marks. Like you get 0.5, 0.5 for definitions, at least, depending on your professor. But formulas are very important, so you should also stick them in your head and put them on paper. Yes, during your exam, your interview, whatever. So v theta dt is r d theta c dt, and we said r, that's this r, where's it? Yeah, this r is 2 minus exponential minus t, and then we derive the theta over dt, that is, we derive this. So what's the derivative of this? P pseudo pi over 2 is a constant, so out, and the derivative of minus t is minus 1, so we're having minus 1. So this is the same thing as minus 2 minus exponential minus t. So now we are done with answering the first part of the question where I say determine the composant radial and transverse gravitas. We have to determine the, okay, the next thing we are being asked to do here is to, no, the second part of the question is to represent at l'instant t égale à 0 secondes the vector position OM suivant l'échelle 2 mètres to 1 meter. Okay, for now we are going to be concerned about answering this party like this. Of course we are going to do this, but let's first know our calculation first. So we're going to do the vector position OM. So what do we have? A, we say it's le vecteur position, that's 2A, le vecteur position OM at t equal to 0. So since we are doing it OM in function of time, what's the time? 0 seconds. So we have OM 0. Okay, so break it into the listen, because we have r and we have theta, so we have to work for r, we have to work for theta. So we have r 0 second is equal to 2 minus e raised to the power of 0. So we just replace t by 0 because we're working with t at 0 second. So exponential minus 0 will give us 1, and so we're having 2 minus 1 is equal to 1 meter. The next thing is theta at 0 second. Our theta we say is minus t plus p pseudo. So if we replace this 0 plus p pseudo, this will give us, this will cancel 0, so we're left with p pseudo met. Remember this, the units we said it's is in meters, so this. And remember, like, okay, let me remind us again of our definition of OM. We said this R, in this case it's ROUR because it's at 0 second. Then what is the next thing we're asked to find? We're asked to find the B part will ask to find the vector vitesse. So we have the vector vitesse V, and that's at 0 seconds, so it's V0. So we're dividing it into our two components. We have VR0 and V theta 0. So at VR0, remember our definition of VR function of time. We say is normally is dr over dt. So remember it's at 0. So if we derive, so what we're going to do is to derive R0.